Good day everyone. We continue with chapter 8 and today we'll be looking at subtopic 8.4 continuous probability distribution, the normal distribution. So what is normal distribution? Normal distribution is a continuous random variable x having probability distribution function as this. And normal distribution can be expressed as x and referring to normal, and mu is mean, and sigma square here is variance. So if sigma square is variance, then standard deviation is sigma. And we have a special type of normal distribution which is called standard normal distribution. And for standard normal distribution, mean must be 0 and variance or standard deviation must be 1. So therefore, standard normal distribution can be expressed as Z, which is in this case Z is reserved only for standard normal distribution. Z is a normal distribution with mean 0 and variance 1. So as we can see here, the probability distribution function of normal distribution is quite complicated. So probabilities of normal distribution are listed in a table called standard normal table, but this list of probabilities is only for standard normal distribution. For any common or any ordinary normal distribution where mean is other than 0 and variance is other than 1, we have to convert it into standard normal first, then only we can refer to the table of probabilities. So this is how standard normal table look like. These are the values for Z and these are the probabilities. The standard normal table is said to be standard normal probability in right hand tail because all these probabilities are for value of Z greater than 0. In case of Z is given as lesser than 0, then we have to convert it into Z greater than 0, then only we can refer to this table. Let us now look at example 11. If Z is normally distributed with a mean 0 and variance 1, so Z is said to be standard normal distribution with mean 0 and variance 1. So find probability of Z greater than 1.87. So from this curve, we can see that the area for Z greater than 1.87 is at the right hand tail. So means we can refer to the standard normal table to find the probability. So let us look at the standard normal table for this probability. So this is the probability of Z greater than 1.87, which is 0.0307. Therefore, the probability is 0.0307. B. Find the probability of Z lesser than negative 0.63. So observe that the area for Z lesser than negative 0.63 is at the left hand tail. Remember that the standard normal table only gives us the probability if the area is at the right hand tail. So we can actually convert this into the right hand tail. As you can see, it's actually the same area because it's symmetry. So therefore we can say that probability of Z lesser than negative 0.63 is actually equals to probability of Z greater than 0.63. So if we write it into this in this form, then we can find the probability straight away from the standard normal table. So let us look at the value. So the value of Z greater than 0.63 is 0.2643. Therefore, the probability is 0.2643. C. Find the probability of Z lesser than 0.29. Observe that when Z is lesser than a positive value, we can see that the area is starting from the positive towards the negative value. So it actually has crossed over from the right tail area towards the left tail area. So to find the probability for this, we can take the whole area minus this small area here, which is equivalent to this area. So the whole area minus this, what we have left is the required area here. So the probability for this whole area is 1, and now we can find the probability for Z greater than 0.29 from the standard normal. So from the standard normal table, we found that the probability for Z greater than 0.29 is 0.3859. So therefore, the answer for probability Z lesser than 0.29 is 0.6141. Question D. Find the probability of Z greater than negative 2.21. So this time, we are asked to find Z, and Z is greater than a negative value. So we can observe here that when Z is greater than the negative value, then the area is actually cross over from the left hand tail to the right hand tail. So the easier way to find the probability for this is by taking the whole area, which is probability is equals to 1, minus the small area here, which is this one. So when the whole area minus this small area here, what we get is the required area. So therefore, probability of the whole area is 1, and now we can find the probability for Z greater than 2.21 from the standard normal table. So from the standard normal table, the probability of Z greater than 2.21 is 0.0136. Therefore, the probability for this, the probability for Z greater than negative 2.21 is 0.9864. Observe that when the area is like this, which is almost the whole area, the probability must always be very close to 1. Question E. Find the probability of Z in between 0.52 and 1.05. Observe that Z this time is in between two positive values. So we can imagine that the area for Z, it is still at the right hand tail. So that's how it looks like. So to find the probability for this, we can find the probability for this bigger area here minus the probability of the smaller area here. So that's how it looks like. And since both areas at the right hand tail, so we can find this right away from this standard normal table. So now we find the probability of Z greater than 0.52 and probability of Z greater than 1.05. So from the standard normal table, these are the values, and therefore the final answer is 0.1546. Question F. Find the probability of Z in between negative 2.86 to negative 0.42. So we can see that z, this time z is in between two negative values. So we can actually imagine that the area of z is at the left hand tail. So that we can see this. The area is at the left hand tail. This is z 0.42, negative 0.42, and this is z negative 2.86. So to be able to find the probability for this area, we have to transfer this to the right hand tail, and then so that we can refer to the standard normal table. So there it is. This area here is equivalent to the whole area here, and minus the small thing, which is minus that small thing. So therefore now we can find the probability of z greater than 0.42, which is from here to there, and minus the probability of z greater than 2.86. So find the probability from the standard normal table. We get these values, and the probability for z in between negative 2.86 to negative 0.42 is 0.3351. G. Find the probability of z in between negative 0.33 to 2.31. So observe, this time z is in between a negative value and a positive value. So we can imagine that the area for z is from the negative towards the positive. So it's actually crossover from the left hand tail towards the right hand tail. So how do we find the probability for this? It will be easier if we take the area of the whole thing minus this area and minus this smaller area here. So if you do so, then what we have left is this area. So the probability of the whole area, the whole bell curve, is 1 minus the probability for this area, but we transfer that to the right tail. So this is how it looks like, and minus this smaller area here, which is this. So now we can find the probability for z greater than 0.33 and probability of z greater than 2.31. So from the standard normal table, we find the probability for z greater than 0.33 as 0.3707, and the probability for z greater than 2.31 is 0.0104. Therefore, the probability for z between negative 0.33 to 2.31 is equals to 1 minus 0.3707 and minus 0.0104, and it comes to 0.6189. Okay, last question of example 11. Find the probability of z greater than 1.94 or probability of z lesser than negative 0.94. So there are two areas here. One is lesser than the negative value, so it is this side, and the other one is greater than positive value, so it is at this side. So to be able to find the probability for these two areas, what we need to do is just transfer this one to the right tail so that we can find the probability for it. So this is how it looks like. So now we can find the probability for this area and the probability for this area. And from the standard normal table, we found that the probability for z greater than 0.94 is 0.1736, and the probability for z greater than 1.94 is 0.0262. So therefore, the final answer for this question is 0.1998. That's it for today. Thank you and have a nice day everyone. Bye.